What's going on, everyone? In today's video, we're going to take a look at the same trig ratios we have, but yet we're going to use them slightly differently because in the past videos, what we've been looking at is, hey, can we use these trig ratios to figure out what the missing side is? In this case, what we're going to do is use the sides to figure out what the angle is. How can we do that? Well, let's find out. So how can we work out what this angle alpha is? So when I think of SOHCAHTOA, what am I thinking about? Well, I'm thinking about, okay, relative to my angle, what am I using? Well, this is going to be the opposite, and this is going to be the adjacent. So I'm going to be using tangent. So the tangent of alpha is going to be equal to opposite 3 over adjacent 4. Now, how do I figure out what my angle is? So what I want you to think about is how can we undo the tangent function? And it really helps to think about how do we undo multiplication? Will we divide? How do we undo subtraction? Will we do addition? And these are inverses to each other. And so perhaps on your calculators, you've seen a trig function that looks kind of like this, but you've seen a little -1. Kind of as an exponent. It is not tangent to the power of -1. What it stands for is the inverse function of tangent. And that's really important because if we actually take the inverse tangent of each side, what this does is, again, remember that inverses just simply undo the regular function. Again, that's not the most mathematically correct term, but hopefully that makes the most sense to you. So again, we had a function, in this case it was tangent, and all we did was we used the inverse tangent, the inverse of that function. It could be inverse of cosine, the inverse of sine, whatever it happens to be. And then what we would do is, use it on each side, and that way it would kind of take care of the trig function on one side. So what does that mean? Is that it means that we are left with alpha, which is just the angle, and then that is going to be equal to the inverse tangent of 3 over 4, because these two would basically cancel each other out. So what would that mean? Well, if we go back into our calculator, what we can do is just go to inverse tangent, 3 divided by 4, and we'll get 36.8699, 36.9 for me because I am doing 3 sig figs. And remember, we are looking for the angle, so that is degrees. So again, that might seem kind of weird, but again, just think about what you do when you are undoing multiplication or undoing subtraction or whatever it is. You're basically applying the inverse function to cancel it out. And that's exactly what I did here. I used the inverse tangent to kind of cancel out the tangent, so that way I'm left with just the angle inside. So I hope this helped explain a little bit as to why you use inverse trig functions. In these contexts right here, algebraically, we're using them to kind of undo, or I hate to say the word get rid of because but either way, we're using it to isolate the variable, which in this case is the angle. And that is what you're using the inverse trig function for. You're using it to figure out what the variable is. In this case, it's the angle, not the missing side. So when you're trying to find the missing angle, you are going to be using the inverse trig function. When you're trying to find the side, you'll be using the regular trig function. Okay, I hope that helps, and I'll see you on the next video where we go over a couple examples of how to use this.